Good afternoon, Professor David J. De Los Reyes. Okay, my topic this afternoon will be a very interesting topic. It's the perimeter of a rectangle. Okay, we will derive by integration the perimeter of a rectangle as a function of the length and the width. Okay, let's proceed, guys. My lesson this afternoon, as a summary, this will be lesson number 86 on my channel under the topic Integral Calculus, under the subtopic Length of Arcs. And the main topic for this afternoon is the derivation of the perimeter of a rectangle as a function of its length and width. The formula we are using under lower mathematics, under solid mensuration, in which the perimeter of a rectangle is actually twice the length, or sorry for that one, twice the product of the length and width. Okay, not all professors who are teaching lower mathematics under solid mensuration, they are using perimeter as this, but they don't know where it came from. Actually, perimeter as a product of the number 2 and length times width actually originated from integral calculus. Okay, let's proceed. I will try to read the problem, guys. Derive by integration the perimeter of a rectangle, the length n with the length L and width W. Meaning, we are given a rectangle, we are given the length, and we are given the width. Okay? So we will try to solve the perimeter, the total distance going around. That's we call it a perimeter for rectangle, because for a circle, we don't call it a perimeter, we call it circumference because it was round. But for a rectangle or a square, the total distance going around is actually termed to as perimeter. Okay, let's proceed. We will try to graph the rectangle on the Cartesian coordinate system. Don't worry, it's just a plain thing. We are not involved on the XYZ plane. It only involves two axes, that is the x-axis and the y-axis. So if we try to draw a rectangle on the XY plane, okay, we'll put it on the first quadrant. So all the numbers will be positive, okay? So this should be the length of the rectangle. This is the width. The specs of the coordinates of this point here will be L and 0. This is L, vertical height is 0, so this is L0. This corner here will be L and W. This is L and this is W. This one here will be, it falls under the y-axis, so the value of x or abscissa will be 0 and the height will be W. So this is W, 0 and W. The first one, which actually coincides with the origin, the x at this point here is 0, meaning the abscissa, and the ordinate is 0. So actually the coordinates of this one is 0, 0. Meaning x is 0, y is 0. Okay, we try to cross hatch the rectangle so we could visualize it. Okay, so the one in cross hatch is actually the area inside the rectangle, and the problem is asking derive the formula for the total distance going around. Actually, under lower mathematics, mathematics teachers which are teaching perimeter to be twice length and width, I don't know if they know that this came from or emanates from integral calculus. Actually, perimeter as a product of the number 2 times the product of length and width actually emanates from integral calculus. Okay, let's proceed. For the solution, length of arc is actually originally the square root of 1 plus dy dx quantity square times dx. Okay? I put two formulas over here because as you notice it, to compute for the total distance going around, we will take this length here, then we multiply it by 2. That's why there is a 2 over here, right? And the second total distance will be this side here, times 2. This is 1, this is 2. So this is times 2. On the first one, the differential thing is actually dx, because it was a horizontal distance. This is a horizontal distance, so the first equation will be multiplied by dx. So dy inside is actually dy dx quantity squared. The second one, the second distance is actually a vertical height, so we could not use this one. So we will use equation number 2. That will be the square root of 1 dx over dy times dy. This is a vertical height, so it should be dy. Okay, this is a horizontal distance, so this should be dx. So this times 2 here refers to this is number 1, this is number 2, this is times 2. Okay, the vertical height will be number 1, number 2, so this is times 2. So the total distance going around the rectangle is actually the sum of this one here, that's this. Okay, it's not magic. For the first horizontal distance, what we need should be ay equal to a function of x. Okay, for the vertical distance, what we need will be x as a function of y. Okay, but if we try to get the equation of the this line here, this one, okay, the equation is actually y is equal to w. It's a horizontal distance in which the value on the right hand side is equivalent to the width of the rectangle. That's why for the first equation, I put it here, y is equal to w. It is the horizontal part. It is times 2 because this is 1, this is 2. For the second one, this should be a vertical line, so the equation will be x equal to L. Okay? The abscissa at this is a straight vertical line. So if we try to get the equation of this, x will be equal to L, equal to the length of the rectangle. It is this. Okay? Okay, let's proceed with number 1. Since y is equal to w, and luckily we do not have an x on the right hand side. Luckily, okay? Because y is equal to w. So if we try to take the value of the derivative with respect to x of y equal to the derivative with respect to x of w. Basic, right? What you will do on the left, do it on the right. The derivative with respect of y is actually dy dx equal to the derivative with respect to x of w. W is constant. Okay? So if you try to take the derivative with respect to x of w, it will be 0. Right? Squaring both sides, dy over dx quantity square equal to, right hand side is 0 square, 0 square is 0. For the second part, I'll try to remove this one. X is equal to L. And luckily, x do not have a y term on the right hand side. It is just a pure constant because actually x is equal to L. Okay? And we need dx dy, right? So differentiating both sides with respect to y, the derivative with respect to y of x equal to the derivative with respect to y of L. The derivative with respect to y of x is actually dx dy. The derivative with respect to y of L is also constant. Okay? For any rectangle, the length is constant. So the derivative with respect to y of L, this will be 0. Squaring both sides, dy over dx quantity square equal to, the right hand side is 0. 0 square, use your calculator, it is 0. So we now know dy dx quantity square. We now know dy dx quantity square. We put it back here. Okay? So differential length of arc. the total distance going around. Okay, it will be 2, we are following this, the square root of dy dx quantity square is 0 times dx plus 2, the square root of 1, dx over dy quantity square is also 0, this is times dy. Okay, ds now, the total distance going around, equal to 2 dx plus 2 dy. This is the differential equation. And to take the total distance going around and its term perimeter for a rectangle, take the integral of both sides. Right? For dx, okay, we try to specify the limit. For the vertical distance, okay, for dx, horizontal distance rather, x should move from 0 to L. That's why the limit is 0 to L. Okay? For the vertical distance, okay, y should move from 0 to W. So the limit is actually 0 to W. Right? So the integral of the differential length of arc is just the length of arc equal to 2. We move it out. The integral of dx is x with the limit from 0 to L plus 2. The integral of dy is just y with the limit from 0 to W. Substituting the lower and upper limit for the two terms, it will be 2 L minus 0 plus 2 times W minus 0. Okay? S now, and it is termed perimeter, and for a rectangle, hypothesis perimeter equal to, this is 2L, 2W, so this should be 2 times the product of length times width. So perimeter for a rectangle is actually twice the product of the length times width. So for those teachers who are using, or professors teaching lower mathematics, they are using perimeter for a rectangle as twice the product of length and width. This is where it came from. It emanates from integral calculus. So what you are using under lower mathematics, that is perimeter for rectangle as the product of twice the length and width, actually emanates from integral calculus. Okay, good afternoon, Los Angeles.